Hey there, welcome back to another video. So in this video, we'll be talking about different Python libraries, how to use them properly and when to use them. So I have this list of libraries that I'll be going through over the series of videos. I'll be showing you exactly how to use them properly with live demonstration. So NumPy and Pandas are widely used for data analysis. Matplotlib C1 and Plotly widely used for data visualization. SciPy is there for statistical evaluation. Now machine learning, we use scikit-learn or sklearn. Now PyPython and Python is there for visualization of protein structure. LangChain, TrueAI, AutoGen, and LangGraph are widely used for AI agents making. So if you want to make some AI agents using these libraries, I will be showing you that also later on. Now I'll be moving ahead with Pandas first. So I'll show you how to use Pandas in real datasets, how to do basic data analysis first, then I'll move ahead. So without further delay, let's begin with the Pandas. Need to install it. So just need to run pip install Pandas first. Since I've already installed the Pandas earlier, so that's why it is showing the requirement already satisfied. You need to install the Pandas first, then you need to import your library in your system that you are running right now. Import Pandas as PD, then you are good to go and your system now has imported the pandas library. Now you can call upon this library. I'm assigning the pandas as a PD, so that's why I'm calling the pandas as a PD, dfpd. I'm making a data frame. In the data frame you can store your designated values and your column information. So I'm assigning some value here for a. I'm putting random values just to show you how to make the data frame. Now you can print this. So this is how your data frame looks in Google Colab. So this A, B, C can be anything. You can put any keys based on your requirement and any values in the array as well. Now make sure when you are building a data frame, your array length of ABC needs to be equal. Like you cannot put 5 element here, 3 element there and 2 element there. That won't be possible in that way. So you need to have equal quantity of element in the arrays. Now you can isolate any column if you want. Suppose I'm going to isolate the A column. I'm going to just use df in bracket A and it will be giving me the exact column from A key. Now if you want to get the dfb, you need to run dfb. Now if you want to get the total sum of dfb, you can get, let's say it is 68. You can get also the median value using df median. You can get the mean value of dfb, which is 20.6. You can get the max. You can get the standard deviation. Now I can show you the more descriptive type of function in pandas using describe. Now it can show you, it can give you the exact ABC descriptive statistics using df.describe function. So see, this is what it's giving me, df.describe. So basically describe is doing the entire data frame in descriptive statistics manner. So it is giving me the standard deviation, it's giving me the mean value, it's giving me the interquartile range, 25%, 50 and 75% is there. I can get the max of it. I can get the basic data type info. So what kind of data type is there in my data frame? So for that I'm gonna need df.info. So it is giving me that all the data types are integer. int64 basically integer in pandas. So that's it. And now I can show you an biological example first. So let me create a data frame for this. So suppose you ran an experiment on basic gene expression analysis using PCR. Now if you have a gene called BRCA1, right? We know BRCA1, what BRCA does. So I'm just giving some values of CT values. These are cycle threshold values that you get from running PCR. So BRCA1 has 3 CT values. Now I'm going to give BRCA2 some CT values. These are imaginary numbers that I'm putting just to show you an example. So I need a control. Control would be 30, 31, 33. Now I need another control. Since I have two genes, I need two controls. Control 2 would be 31, 30, 32 and 35. Now I need another housekeeping gene, right? For that I'll be using gap dh. Assign some value here, would be 18, 15, 17. Now this is our data frame. Let's call the data frame first. So this is our data frame. It contains 3 values for BRCA1, 3 values for BRCA2, and 3 values for each controls, and 3 values for gap dh. Now what I want to do, I want to analyze the fold change using del ct method for BRCA1 and BRCA2. I'm gonna put some new columns in the data frame, and each of this column will be helping me to get the final result. Let's do this. First I'm gonna do del ct first. We're gonna need del BRCA1. So del BRCA1 will be df BRCA1 minus df gap. Now repeat the same for df BRCA2, and I'm gonna need df del c1 and df c1 as well, and gonna minus it from df housekeeping gene, that is gap, and I'm just gonna copy it and replace the 1 with 2 for control 2. Now what we can do, we can get the mean of control. So control c1 mean would be df dot mean. You can use mean function to calculate the c2 as well. Now we can calculate the del ct using df del BRCA1. Yeah, so this would be, I want to put it here, and I'm going to minus it from control mean. Just copy it, paste it, and replace the 1 to 2. That's it. Now del ct has been completed. Now we'll be moving to the fold change of BRCA. Fold change. For that I'm going to need now some new variables to put in the data frame, which is fc BRCA1, and I'm going to use 2 to the power minus this del BRCA1, and this will be repeating for BRCA2 as well. I'm just going to replace this 1 with 2. That's it, and let's run this. So it just ran perfectly fine. Now we can call upon our data frame. Let's see how it's looking. So as you can see, we have incorporated del BRCA1, del BRCA2, del c1, del c2, and del BRCA1 and del BRCA2, and fc BRCA1, fold change BRCA1, and fold change BRCA2 is there. So this is how you can calculate the fold change of your target gene that you want to analyze using Pandas. So I hope you understand this. So basically our existing data frame contains only the BRCA1, BRCA2, and control 1, control 2, right? So, and there was a housekeeping gene only. So this is our pre-existing data. We build additional information based on our analysis. We build delta BRCA1, delta BRCA2, delta control 1, delta control 2, and also the delta BRCA1, delta BRCA2. Then based on that delta BRCA1 and delta BRCA2, we did some fold change calculation using 2 to the power minus del ct values. So these are all the analysis you can do with the city values, your requirements. Now we can do multiple replicates as well. That won't be any issue. So it takes lesser time to analyze in Pandas compared to the any Excel or whatever you use basically. So I hope you got this. So now let's move with a proper CSV file. So in order to upload a CSV file in the Google Colab environment, you just need to run this code, which is from google.colab, import files, upload files, upload. Just run this and window will be opening, and you can choose your file from here, and you can upload your file that you want to analyze. So I'm using this file. I'm just gonna upload it. Now it's already uploaded. Now to read this file, just use this df equals to pd dot read csv and put your file name here, and let's. So this is the data as pandas reading instantly. Now data contains 150 rows of data, 5 columns is there, gene, condition, replicate, expression and category. So our data contains numerical and non-numerical data as well. So we can evaluate using various functions like group by, pivot table, etc, etc. Now I'm going to show you few basic things in pandas. In order to check the data set first, you need to do df.head. Now df.head is going to give you first 5 rows of your data set, first 5 rows of data from your dataset. Now if you can extend it using 10, 20, whatever you want, you can extend, and that amount of data, that amount of row you will be getting from the pandas dataset. Likewise, you can use tf.tail as well. It will give you the last 5 rows of your data from the dataset. You can extend this using same like head we have seen. So now it will be giving you the 10 rows of data from the lower section, last section. So you can slice through your dataset using df head and tail accordingly. Now there is also a famous technique that people use to slice through the dataset, which is df iloc. Now df iloc uses a comma which represent a boundary. So before comma you can put your desired rows, and after comma you put your columns that you want to fetch. Like I want to fetch the first row, second row, and when I use the third column. So this will be giving me the exact value of second row and third column position. So it is giving me the 9.78. Now check it out what it shows using df.head. So it is giving me the second position of the row, that is 2, and giving me the value of 9.78. So this is how you can use iloc to specify your data points and get the exact data from your dataset. Now we can also do some basic indexing. Now you can do some basic indexing in the iloc as well. Suppose you want to isolate 0 to 3, right? So for that I'll be using 0 index 4, which is row, and I'm going to use I want to get the data from 0, 1, 2, 3, 4, that is same 0 to 4. Now it's giving me the exact 0, 1, 2, 3, 4, 0, 1, 2, 3. Yeah, since index is always stop before the 4, so that's why I'm getting 0, 1, 2, 3 expression level. Now if you want to extend the 0, 4 to 0, 5, I'll be getting the category also. So this is how indexing can be performed inside the iloc and iloc function, and there is also the lock function. Let me show you how to use lock as well. The lock slightly differs from the iloc because it uses the labeled info rather than any index or positional info, right? Like this. Now I can give the row information. I want to fetch the third row and I want to get the expression level, right? So I'm just gonna put the expression level here, and it will give me the exact value of expression level, which is 7.8. Third position 7.8. Now we can get the 0 to 3 also. It will be giving me the expression level of 0 to 3 as well in the position of value. So this is how you can do iloc and loc, and you can also put some more column info here. Like if you want to put the categories as well, you can put it. Just make sure you are using when you are using multiple columns, you need to use a bracket, otherwise your code will not be executed. So now the expression level and the categories are both are coming. So this is the difference between the iloc and loc. Loc uses the positional and levels information. Now if your column is already labeled, you can use perform loc, and if you don't want to use the labeled information, you can perform with iloc as well, which runs on indexing and positional information. Now moving ahead with rest of the functions. Now to analyze in the pandas, one famous technique is there, which is known as group by. So since our data has already contains various types of non-numerical categories, so I can call upon the group by function to analyze the dataset first. df.group by will be there. Now group by, what group by does, group by uses a categorical non-numerical group category, and it can categorize the numerical data based on that category. So suppose I'm taking this category which is contains in this data set, and I'm gonna put some numerical data which is our expression level. Now I'm putting the expression level here. Now I'm gonna do a aggregation function using mean. Now let's run this. So this is giving me the exact group by information of expression level for each categories. Now we can change the mean, like you can use sum also. So it will be giving the total sum value of each categories based on your expression level. So in order to run multiple aggregation function, you can just do this aggregation mean sum. We need to use a bracket in order to put the mean and sum totally in the data frame, otherwise it won't show properly. So now it's coming. So we can also sort the values of aggregation, sort values, and by mean, I'm using mean, ascending would be false. That means we are descending, the value would be in descending order. Let's see. Yeah. So see, our values got descending order based on the mean. So based on our mean, we sorted our values using mean and ascending false. That means higher value would be our higher section, top section, and the lower value would be our bottom section. So this is the descending order of values. In our data set contains various categories. We can check the what is the actual counts of unique categories that are present in our data set. For that, we can use df value counts, and I'm going to use category since I want to find out what is the count of each categories that are present in the data set. See, Python is highly case sensitive, so make sure that your spelling and your alphabets are exactly matches with your dataset. Otherwise, it will show you an error. So we have stress response has 53 counts, which is the highest count. Metabolism has 38 counts. Signal transduction has 31 counts. Transcription has 28 counts. So our stress response has highest number of counts compared to the rest of the categories. Now we can also check the conditions. What are the different types of conditions is there? So we have even number of conditions, which is control, treatment A, treatment B. So that's fine. Now we can also do some pivot analysis, pivot table analysis. So let me show you what pivot table is. So pivot table comes with pandas 50well. So I'm just going to call pivot dot table, and I'm going to give some values over here. Values has to be numeric. So we have our expression, right? We have our expression data, expression levels. Since it is a numeric, we can copy it. Expression level, I'm going to put it here, and I'm going to need some index would be our gene. And for columns would be our non-numerical categories that are basically condition, and we can use multiple non-numerical categories here. We can use categories as well, category. And since we are using group by, so pivot table also uses a group by function in the curtain, behind the curtain. So that's why we're going to need an aggregation function. So the aggregation function can be mean, so that's not a problem for this. Now let's run this. Now I just gonna call the pivot. Okay, I got an error. Okay, forgot to put the data frame. You need to put the data frame here, otherwise it won't be possible to create the data table that we want to see as a pivot table. So this is what it's doing. It's grouping, basically doing group by function based on the condition and categories, and we are getting the values for each gene. This is the index of gene, and this is the index line, and this is the control, treatment, and treatment B. This is the condition, and this is the categories: signal transduction, metabolism, stress response, transcription. These are all categories, and we are getting the expression level for each of these categories based on the index. So this is how we can perform pivot table and get the idea of your dataset. Now we can do the same based on your group by function, but the representation of data set of this output dataset would be completely different. Let me show you how. So let's dive in and do some group by, df.group by, and give some categories name. I'm just gonna copy it here. So this is our categories, and I'm going to use a bracket for this since we are using multiple columns over here, and I'm going to use expression level, and I'm going to use mean since we have already used mean for the pivot table also. And let's see what it's going to show. So this is what it's showing. This is the condition, this is the category, and this is the expression level. So see the representation of the data style, its data set. The style of the representation is completely different from the group by and the pivot table, but both of them are doing the same thing. The data is same, just the representation style is different. So that's the basic group by and pivot table. We can find out the max expression level using just max. It is 14.3. Now let's check which categories it is hitting max. tf.category, and wanna use expression level, and wanna use the mean will be fine, and it show me. So it's giving me the mean value, right? Okay. So in order to find out, we can't use the group by because it is always comes with mean and other aggregation function, right? So to find out which categories this expression level is belong, max expression level is belong, we can perform sort values using multi-column approach. So what we can do, we can put the expression level that we want to find out, and We can put the category as well. You can put the category as well, and now we can do some sort value function that we've already seen in group by. Same sort values can be applied here. Sort values, sort values by expression, since we are finding out the max expression, and expression would be our expression level, and expression level would be ascending false, since we want to find out the max. So let's see how it shows. So it is giving me the 14.83 in stress response. So stress response has the highest expression level. Now you can also get the, let's see what it is, zero index source. Now if you want to get the one, so it is showing us the exact expression level in stress response, which is max 14.83. So we can also perform indexing side by side along with the uh, code basically by pandas. So if you give 0, it will show you the column name only, and if you put 1, it can show you the exact highest expression level along with the categories. Now if you put 2, it will show you the second highest as well. So this is how you can do the basic analysis, basic exploratory data analysis using pandas. So this is the expression, highest expression. This is the second most. This is the third. This is fourth, which is metabolism. So stress response has the highest expression level. But here we can see that the metabolism has the highest mean value of expression. So that means our metabolism is winning in terms of category wise mean over the single highest peak of expression level. So overall, in terms of overall performance, metabolic expression level is winning compared to the rest of the categories. So I hope you got the basic understanding of pandas here. You can rewatch this video and learn these things out on your own. So see you on the next video. Tata, bye bye.